God. Just Alright, we're gonna start in like 2 minutes, so get your homework or whatever out. Ready to rock. You have to explain what all these things mean. Pogger? I don't know what a poggers is. What's a pogger? It'll say just double the time. Alright, put the number in chat that you want to do first. The number, which problem you want to do first. Put the number in chat you want to do first. Oh, Barack Obama's in chat. Whoa. Hey, Obama, you're a really overrated president. Like, I mean, compared to Trump, like, you're great. But, I mean, you know, people think you're awesome, but you were only okay. So, sorry, but that's the truth. You still deported hundreds of thousands of people, and you still did drone strikes in the Middle East and killed civilians. So, you know, you were only okay. You weren't that great. 2, 2, 3, 2. Okay. How you stream snipe of physics stream manual? That doesn't make any sense. Okay. Alright, welcome to Chandler Science live stream. This is my first time ever doing this, so it's probably really ghetto looking. I don't care. We're doing the homework. Projectile motion homework. We want to do number 2 first. You mean this number 2 or a different number 2? I assume you mean this one. I don't know. Tell me what you mean. Because there are 2 number 2s. This number 2, a bullet is fired, or this number 2, but in a tall building, a certain window. Which one? The first one? Sorry, there's 2 number 2s. I know. I forgot to renumber them. First page. Okay. All right. Okay, bullet is fired. All right, so this is the general setup here. We're going to write down what we know. Okay, guess method, right? Bullet is fired with initial velocity at 22 meters a second at an angle of 8 degrees from the level ground. All right, so we're going to always draw the picture. It helps. 226 meters a second. The first step, I think I mentioned in this class, always draw your component. So we're going to have our horizontal component of velocity and our vertical component of velocity. This is 8 degrees, right? Where's my calculator? Hold on, time out. Oh, it's right next to me. It's literally right here. All right. First page, all of them. The Astros game, low-key whack. It's all about them. Mundo streaming from the Astros game. Go Stros. All right. So okay, we're gonna find components, right? So the motion is 2-dimensional, so we can't really, it's easier to break things down. Instead of solving a 2-dimensional thing, we want to break it down into 2 individual 1-dimensional things, if that makes sense. So instead of doing 2-dimensional things, we need to break down a 1-dimensional thing and a 1-dimensional thing, and we kind of think about it separately. So we got to find this side. This side is opposite the triangle. It's a right triangle. This, let me get a different color. This side here is opposite the triangle, opposite the angle, I mean. So we can do that with sine. So we do sine of our angle equals opposite, which is the vertical velocity, right? This is the vertical velocity side here. So Vy. That's the opposite side of the triangle. Say something in chat if something doesn't make sense. Ask a question in chat. And subscribe and like and do all those things. That's the thing you say, right? That's what you say? I don't know what the fuck I'm doing. Alright, and then below that we have the hypotenuse, which is 226, right? That's the resultant velocity, the total velocity. Hypotenuse is 226. So we multiply both sides by 226 to get our Vy. So it's going to be 226 times the sine of the angle, which was 8 degrees. Make sure your calculator's in degree mode or you're going to have a bad time. So not a lot of light in here. 226 times the sine of 8, and I'm getting 31.45. So this is going to be 31.45 meters per second. All right, and then we're going to do we also might as well do the horizontal component while we're at it. So that's going to be Vx, right? Little subscript for the plane we're in, horizontal plane or the vertical plane. So this will be 226. It's the exact same thing. I'm going to replace the cosine with, the sine with cosine. So 226 cosine of my angle, which was 8 degrees, and that's going to give me Vx. And again, the reason why, this side here that I just drew in purple, that side, that's adjacent to the angle that I know, right? Not counting the hypotenuse, it's touching it. Adjacent means touching, essentially. So it's touching the angle, it's adjacent to it. So ca toa, right? Cosine of my angle equals the adjacent side, which is Vx. That is the triangle Vx, over hypotenuse, which is again 226. So that's where this came from. All right, do the math. 226 cosine of 8, and I'm getting 223.8. 223.8 meters per second. All right, now I have my components. I have my vertical component here and my horizontal component here. Now, what was the question asking for again? Determine the amount of time the bullet spins in the air. Oh, actually, I didn't even need to find the horizontal component. Whoops, my bad, but I did anyway, so bonus. All right, so projectiles go like this, right? They launch up in the air, fly through the air, and they land, right? And there's a special spot at the top, right? At the middle, the peak of the trajectory. If we know that spot, what is poggers? What does that mean? God, someone explain. I don't know what it means. At that top spot right there, right? It's a special spot. It's special, like manual, right? The vertical velocity only. Don't say the velocity is 0. That's not true. The vertical velocity is 0, right? It stops going up because gravity's slowing it down. So it still has horizontal velocity, but its vertical velocity becomes 0. All right. So we're trying to find how long it spins in the air. All right. So we know. So ask ourselves, okay, well, how long does it take to go from this launch to this halfway spot, right? How long does it take to go just to here? And if I know how long it takes to go there, and once I find that out, and I double it since that's halfway, then I'll know how long it takes in the air for the whole time, right? Better TV Twitch emote. World ain't ready for his game. You don't want my gaming streams to be terrible. I'm not good at game. I play like turn-based games because I can't play real games. Okay. Oops. Sorry. All right. Where was I? Okay, so we want to find the time halfway. We double that, and we get the full time. So how long did it take to get to here? Well, if we know the final velocity at this spot here is 0. We know the initial vertical velocity. So let's write this down. Vy initial naught is 31.45. We know that the final velocity vertically at this spot here is 0. We know acceleration is -10. And we are going to try to find the time t. So one of the equations is v equals v naught plus a t. Keep everything in the same plane, right? Don't mix your planes, okay? So everything's in the y plane, the vertical plane. A is -10 times t. Initial vertical velocity was 31.45 equals our velocity at that, what we're calling the final spot right here, right, is 0. So I'm going to subtract 10t over, so I get 10t, or sorry, add 10t because it's negative. So 10t equals 31.45. I divide by 10, I get t equals 3.1, call it 15. But that's only halfway, right? That's the halfway point. And if your launch and your landing spot are the same altitude, this trick works, right? Find how long it takes to get to the halfway point and then just double it. So 31.15, double that, so times 2. Our total time is 6.3 seconds. Okay, and that's your final answer. Urban Dictionary Progress, a descriptive of a scruffy, shabby, cheap, otherwise low-quality person. Place article. You saying I'm a low-quality person? That's pretty messed up. Who's Panda V? I know where you live. Alright. Alright, what's next? Oh, it's Gabriel, okay. Particularly after an impressive play is made popular. Oh, okay. Alright. What's next? That one. So hopefully half the problems are like this one. You know? It's the same setup. Like they're just asking it different ways, but they're all pretty much the same as this one. 3. The next one? Alright, I'll do the next one. I got a feeling I'm doing all of these, aren't I? Okay. Let's go to a different color, just for fun. That's fun. Colors are fun. A little blue. Okay, number 3. Alright, this time we got an artillery shell. It's fired. Again, it gives us the initial velocity of 350. So if I do it in here, can you all see this okay? 350 is a total speed, right? At an angle of 30 degrees. So we got to find components first. That's always the first step. This angle here is 30 degrees. 30. We got a vertical component, and so we're gonna do yeah, dude, you should have like some of these done. Come on, man. They're on second page. Oh, not this 3? A different 3? I'm waiting for chat. There's a lag, so I'm waiting for her to respond. I'll do this one real quick. It's fine. Okay, so find my components. So it's always going to be the hypotenuse 350, the resultant velocity, times the sine of the angle, which is 30 in this case, to get Vy. So in this case, Vy is going to be sine of 30 is a half, so it's going to be 175. Vx will always be the hypotenuse 350 times the cosine of the angle, which is 30 in this case. So this is going to be, I can't do that one in my head. It's cosine of 30 times 350 is 303.1. So it's 303.1. Oh, I'll do this one anyway. Meters per second. All right. Okay, so now we have our components. Again, that's always the first step. So hopefully you're good with finding components. How much time passes before the shell strikes the ground? So they're asking the same thing, right? How much time passes before the shell strikes the ground? It's the exact same question as number 2. They just word it differently. Number 2, they say it's very clear. Determine the amount of time the bullet spends in the air. It's very clear and clear cut, right? But in 3, they say how much time passes before the shell strikes the ground. Well, it's the same question, it's worded differently. Well, if we launch it up in the air, comes back down, and then it strikes the ground, right? So how long is it in the air for? It's the same question. So again, at this magical spot, at the peak of the trajectory, we know that the vertical velocity is 0. Vertical velocity is 0. So and we know that the initial vertical velocity was 175, and we know acceleration vertically is -10. So we're going to use the exact same equation we just did before. V equals V naught plus AT to find the time, and then we're going to double that time, right, to get the whole time. So this is 0 equals 175 minus 10t. I'm going to do the math in my head, and we're going to get t equals 1.75. But we want to double that because that's only the halfway point, right? That's that's only from here to here. We want to go all the way to the end. So we're going to double this, so times 2, and we get 3.5 seconds. What is Kenny saying? The second time you run as long as possible. Running speed starts. I don't know what he's saying. All right, there's our answer. All right. I'm gonna find out who Barack Obama is in chat, and I'm gonna. I don't know what I'll do, but that ain't Connor. That's not Connor. All right. All right, do part B. What horizontal distance does the shell travel before striking the ground? All right, horizontal distance. Now we have the time. When it asks anything about horizontal velocity, horizontal displacement, horizontal distance, whatever, we don't care about the vertical anymore. Now we're focused on horizontal stuff, right? So don't mix your planes, okay? Isn't it 70.5? Oh, shit, my bad. Yeah, it is. Sorry. I did. Okay, yes, you are correct. Thank you for catching that. Kirby Cannon. All right, Kirby Cannon gets a reward. I don't know who that is, but yes, thank you for catching that, Kirby Cannon. I got my... So it's going to be 10t equals 175, and then t will be 17.5. We double that, so t is equal to 35 seconds. Who's Kirby Cannon? Alright. Okay, so anyway, back to the horizontal stuff. We only care about... Alright, thanks, Matthew. Good job. For horizontal distance, we only care about horizontal information, right? We don't care about the vertical plane at all. Now we have the time. Time is scalar. It has no direction. So we can use the time for both planes because it doesn't have direction. So we're going to use the equation delta x equals v naught t plus 1/2 at squared. But because horizontal velocity has no horizontal motion with projectiles has no acceleration, this whole right-hand side just goes away, right? Because acceleration is 0 in projectile motion. Okay. So now we have left is delta x equals vt. Well, we know how long it's in the air for, 35 seconds. We know our velocity in the horizontal direction is 303.1. So now we can solve for delta x in the horizontal direction. So we just multiply those together, and we're going to get times 35 seconds, and we get 10,608 meters. 0.8 meters. All right, so that's how far this artillery shell will go, about 10 kilometers before coming down to the ground. All right. All right, I'm banning Barack Obama in the chat. I don't handle racist things. How do you kick someone from chat? And if anyone knows who that is, tell me, because I want to punish them. How do you boot someone from chat? First time streaming, don't know how to boot someone from chat. You're lucky. How do you do it? I'm sure I can figure this out here quickly. I can do this, right? I can't click on his name. Oh, here we go. Participants. There we go. Barack Obama. Oh, well, let me... I don't know how to do it. How do you boot him from chat or ban him or whatever? Can someone explain real quick in chat? And I'll do it in a second. Stream options, no. Doesn't give me like a quick way to do it. I don't see anything in here. I should have done this on Twitch. I don't know, who can I trust to be moderator? Oh, duh, thank you. Thank you, Kirby Cannon. Again, Kirby Cannon in the clutch. Why wouldn't the rest of all can say that? Alright, remove. Alright, bye Barack Obama. Alright, I don't need a moderator because I figured it out thanks to Kirby Cannon again. Alright, guys, I'm not gonna handle even remotely bigoted comments. Nothing border. I don't want to handle. I'm not gonna tolerate it ever, on a stream or in class. It's not funny. It's not cool. All right. Okay. So there's number 3. Now you want to do 3 on the second page, right? Is that what we're doing? On the second number 3. Go scroll to it here. This one. Alright, we'll do this one next. Alright, so we got number, this is number 3 on the, second part. Okay. A lot of activity in chat. I mean, hopefully someone's watching this and actually, following along with their homework and doing this. All right, so we have we got a 65-meter tall tower. So let's try to draw this out here. So 65 meters, 65 meters from the top to the ground here. Okay. And we're going to drop a ball straight down to the ground, and we're going to throw a ball also from the same height horizontally, and it's going to go like that, right? And one is dropped from red. Like I said, we read that already. All right. All right. So we don't know what their initial speeds are, but they're going to land 143 meters apart. So this one lands here, and this one lands straight down, and they're 143 meters apart. Meters. All right. And we're trying to find out what the speed of the one that was launched horizontally was. Okay, the key to this is to remembering or realizing that when you drop an object and throw one horizontally, they're going to fall at the same rate. So if we know how long it takes the one that was dropped to fall, how long it takes for it to hit the ground, we also know how long it takes for the one that was thrown to hit the ground. Right? We know how long it takes both of them to hit the ground because everything falls the same rate. I think in class, I'm not sure if it did in every period, but I know it did in fourth, and I think it did in seventh. I might not have done it in first. I don't remember now. But if I take two balls, right, I drop one and then simultaneously throw one horizontally forward. One of them lands over like forward, sure, but they both land at the same time. So if we find the time for one, we know the time for both. So what's time? All right. Well, we know that this thing is going to have a change of displacement of negative 65 meters. Now you can do positive or negative. I like doing negative. Here's why. I like making the ground my origin, my zero position, right? And I like making however high up I am, the height. So remember that change in position is always final minus initial. So I'm starting 65 meters up in the air, and then I'm landing on the ground, which is a 0 meter position, right? So this is final 0 minus 65. So my delta x equals actually negative 65, which makes sense if you think about it, because I'm going down 65 meters. So if I'm going down, we generally call it down negative. So my delta x is actually negative 65 meters in the y plane, right? So I got that. I know acceleration in the y plane is negative 10. And I'm trying to find the time. I know my initial velocity vertically is also 0. So I'm going to use delta x equals v naught t plus 1/2 a t squared to solve for time. This here is going to go away because I don't have any initial velocity vertically because I'm holding on to the ball, right? I just let go of it. I don't throw it. I just drop it. So its initial velocity is 0. Because I have it in my hand, it's not moving yet. So the moment this motion starts, its velocity is 0. So this thing goes away, and I'm left with delta x equals 1/2 a t squared. I know I'm going to go 65 meters, right? Again, vertically. Half of my acceleration is negative 5 times t squared. I'm going to divide by negative 5 both sides. We get 13 equals t squared. Square root that. And that's 3.6. So t equals 3.6 seconds. So it takes that long for this object to fall down to the ground. So if it takes that long for the one that was dropped to hit the ground, it's also going to take the one that was thrown horizontally that long to reach the ground. Now I want to be clear, this only works if the ball was launched horizontally. If you threw the ball like at an angle up in the air from the cliff or down an angle like this from the cliff, this wouldn't work. But because we launched it horizontally and it also has vertical velocity initially of 0, this works. So now we know what t is. We go back and we say, okay, well the thrown ball lands 143 meters from the other ball. So it traveled horizontal displacement of 143 meters. We know time was 3.6 seconds till this thing hit the ground. So we can say, okay, now back to our equation that we can use with 0 acceleration, and that's delta x equals vt. And this one only works when acceleration is 0. And we know 143 meters was my displacement. V is what I'm looking for, and my time was 3.6. So I divide by 3.6 both sides. These cancel, and I'm left with about 39.7 or 40, whatever. So V equals about roughly 40 meters per second. Close enough, right? So that's how fast this guy must have thrown the ball. All right. We vote on the next one, or is the magic? Has the magic over? I lost that magic feeling. How many people are still on the stream? How do I know? 29 people? Holy crap. That's a lot. I feel like that's a lot. Alright. What number's next? Let me know what number's next. Vote on a number. Vote on a question. No one's saying anything. Well, then leave. Now watching me whip. I don't get it. Now watching me nay. 5. Part C on number 5 on the back. Okay. This one. Yeah, this one is. You're gonna kick yourself. This one's so easy. This number 5 here. I don't know what you mean by back. I don't have a copy of the worksheet, so. Yes. Okay. All right. This one. All right. Go with pink. Hot pink. All right. Okay. You're all gonna be mad at yourselves for this one, but this one actually is easy. Okay. I'm sorry. Okay, guys. You know I don't think you're stupid. That's not the thing. Okay. It's experience. I'm sorry. I don't mean to make me feel stupid. Okay. I apologize. All right. We got a rock. So in horizontal. Okay. So in horizontally this way. From the top of some bridge with 17 meters a second. Kenny, shut up, dude. Don't be a dick. Kenny, you're next to get booted if you can't control yourself. All right, and then so we launch it this way, right? And then let me draw it down here better. Well, what can I? It's fine, I guess. And it goes through the air, and it lands, and then 4.2 seconds later, right? It hits water. Kenny's effing himself. I guess that means that he wants to be booted. Okay. Oh, see. Oh, okay, Tony. All right. So we'll just run through the whole thing real quick. All right. So we launch on the bridge, up on some bridge somewhere. Okay, I draw a bridge. Here's the bridge. Okay. I don't know. I can't draw. All right. Whatever. You get the idea. And we launch the ball up, and it hits the water down here. Here's the water. Okay. So we know it says what is the horizontal component of the rock's velocity when it reaches the water? Well, it's 17, right? Because it's horizontal, and there is no acceleration in the horizontal direction. So the horizontal velocity is constant and does not change, right? So the answer is just 17. All right, part B. What is the vertical component of the rock's velocity when it reaches the water? Well, we know it's in the air for 4.2 seconds. We know the initial vertical velocity was 0 because we launched it horizontally. And then we also know that acceleration in the y direction is -10. So we use the equation. This is the first one on the formula chart. It says v equals v naught plus at for the vertical plane. And we're going to, initial vertical velocity was 0 plus a -10 times 4.2 seconds. And we're going to get our answer for our vertical velocity, and it's going to be -42, right? 10 times 4.2. So there you go. That's that one. Now the last part C, is asking us what is the speed of the rock when it reaches the water. All right, so guys, when they say it this way, the total, they're talking about total speed of the rock, right? Well, they're talking about the resultant velocity. What's the total speed of the rock? Well, it has 17. Well, that's a bad line. It has 17 meters per second horizontal velocity, and it has -42. I cannot draw straight lines on this pad. -42, so 42 meters per second down of vertical velocity. Well, those are it's one-dimensional. They want total speed in the two-dimensional plane, so or two-dimensional speed here. So they mean this speed. So all I got to do is do Pythagorean Theorem, right? 17 squared plus 42 squared, and add it up and then square root that, because we're trying to find the hypotenuse, right? Trying to find hypotenuse. Kenny, my webcam won't. I I can't. It's not wireless, so I don't think so. All right, so we got to do Pythagorean theorem to find the total resultant velocity here, right? 17 this way, 42 down. Pythagorean theorem. So 17 squared plus 42 squared equals c squared. So we get 17 squared plus 42 squared, and then we square root that, and I'm getting 45.3. So the total speed, 45.3 meters per second. All right. Well, yeah, but when you square a negative, it becomes positive. So it doesn't really matter, right? 17 squared. All right, here. Plus a negative 42 squared equals c squared. Well, square negative 42. What do you get? You get a positive number, right? Square anything, you get a positive number. So no, it's fine. Don't say you're stupid. Okay. And I apologize if I made anybody feel bad. It just you guys y'all overcomplicate things. You make them harder than they really are. So all right, what's next? Which one do we do next? What's next? Oh, Assad's joined. 31 people. Wow. Okay. 31 streamers. We'll play a game of League. No, we won't do that. I'm kidding. Well, if you put the parentheses like that, then okay, yeah. But that's not what we're doing. We're doing negative 42 squared. I don't play Minecraft. What number's next? No problem. We're doing homework, guys. I want to make dinner. I haven't eaten. Tell me what number is next. Why do I want to know which ones you having problems with. I gave you shout out on Snapchat. Oh, great. Can you go over 4? Which 4, Bianca? The one on the one right here, the one above it. This one, number 4, or the other number 4? This one? My kitchen's way back there. You won't be able to see. This one here? Okay. Kenny, quit being a troll, dude. It's a live stream. It's not a wireless camera. Either. Okay, I think I mean this one. All right, so guys, this one's about relationships. Okay, so it's talking about horizontal distance. So it says, so we have this ball, right, on the table. No eating ASMR. I don't do eating. I can't handle the eating noises. Eating ASMR is the worst. I'll slurp. I can make the noise, but I don't like listening to the eating ASMR. It's oh my god, it makes me want to scream. Cooking with Chandler. All right, so it's got some velocity v, right, and it goes down, and then it lands some distance d from the base of the table, right? Okay, now if we're talking about horizontal, stuff here, we don't really care about the vertical things. Let's focus on horizontal. So the equation to find horizontal displacement, right, is vt. That's it. Okay. There is no acceleration, so acceleration doesn't matter. There is no acceleration. Okay. For horizontal motion. Okay. All right. So here's the problem. If we make this thing roll faster, let's say we double its velocity, we go twice the velocity, we double it. It's going to go further, right? It's going to go like way out here somewhere. And the question is, well, how much longer will this be? Will it be twice the distance, 4 times the distance, 6 times the distance of what it was before, right? That's what the question is asking us. So this is about relationships. Now, if we make the ball speed up faster this way, right? We give it twice the velocity. The question is, does that change how long it takes for it to fall down? I'm waiting for an answer in chat. If we double the velocity this way, does it change how long it takes for the ball to fall down to the ground? If all we change is horizontal velocity. No, Panda Violador is not quadratic. Christian's right. Okay, it does not change how long it takes to fall. Remember, the only way to make the time change for how long it takes to fall to the ground is you change how high you are, right? You go higher, you go lower to the ground, or you change the acceleration of gravity, which you go to a different planet, I guess, or something like that. So just changing the horizontal velocity does not change how long it takes to fall to the ground. So t doesn't change, right? So what is the relationship between delta x, it's the horizontal displacement this way, and velocity? Direct, inverse, quadratic, inverse square, root, or inverse root? The answer was no. It didn't. We're still in chat. Platonic. Okay, that's like kind of funny. You misspelled. I mean. All right, that was kind of funny. Blue is a loser. I don't know who that is. That was okay. But seriously, it's okay. All right, no one's answering in chat. It's a direct relationship, right? I mean, look at the equation. There's no squared sign. They're both in the numerator on the formula. There's no dividing. It's just pretty straightforward, right? So if I double the velocity, if I double one side, t's not changing. So t's basically t ignore t, right? That doesn't do anything. It's not changing. Right? It's all about change. If I double the velocity, I must also double the distance. So if I triple velocity, I'm going to triple the distance. It's going to be 3 times whatever the distance was before. So you get problems like this a lot, right? They don't give you numbers. They just want to know about the relationship between velocity and distance. In this case, if we triple the velocity, we also triple distance because it is a direct relationship. Look at the equation again. Delta x equals vt. T is not changing. If it doesn't change, we don't care about it. And so here we go. It basically says delta x equals v at that point, right? So if we double v, we double x. We triple it, we triple the other one too. All right. Hope that makes sense. I don't know how you donate money. This is my first time streaming ever. So I don't know. But thanks for the thoughts. All right. Hope that makes sense for here. If there's a question in chat, can you post it in chat? I know you guys are having fun in chat. Okay, ha ha ha. But I actually care about the material here. So, maybe you want to like tell me how that's going. If you have a question here. We are underpaid. It's true. All right. The answer is 3D. If we because it's a direct relationship. So if we triple the velocity, we also triple the distance. So answer is 3D. That's the answer. Assad, it's the same idea, same concept about relationships, but it's slightly more complicated with vertical motion because there is an acceleration, right? And with vertical motion, since there's an acceleration, you have to consider the whole equation. So it's more like delta x equals 1/2 at squared. So you have to. So it's a little more complicated of an. So it's actually for vertical motion, it's actually a quadratic relationship. So if you double the time, for example, you would get 4 times the displacement. Gnome Tasty, I don't know who you are, Gnome Tasty, but I probably. How do I'm assuming is it recording this? I don't know. I'll be honest. I don't know what I'm doing. So, do I need to record it? Is there like a way to record and stream, or will it give me an option when I end the stream? Will it give me an option to record it? I really don't know. So I don't know. Maybe number 1 for second, third page. What is a second, third page, Manuel? I assume it. I assumed it was recording, but I don't know. I'm new to. I've been making videos for a while, but never streaming. Second number 1. Okay, second number 1. All right. This one. All right. All right. Okay. Let's draw the building. Got a 50-meter tall building. I cannot draw straight lines in this thing. All right. Here's our building. 50 meters tall, 50 meters from there to the ground, and we're going to launch a sphere, horizontally off the top of the building this way, with a velocity of 14 meters a second. All right, so horizontal velocity, Vx, is 14 meters per second. Thanks, Juan. You're okay. You know, how many seconds after launch does the sphere reach the ground below? All right, so that's all we know is a horizontal velocity and how high the thing is. Wants to know how many seconds after launch does the sphere reach the ground below. So in other words, how long is it in the air for, right? So here's going to go like this, hit the ground. How long did it take? All right, it does not matter at all what the horizontal velocity was. A horizontal velocity could be 14, it could be 14,000. Doesn't make a difference, right? Okay, with one caveat, if you did launch it fast enough, it would actually, the curvature of the Earth would come into effect. But let's ignore the curvature of the Earth. That's too complicated. All right. Let's assume a flat Earth. Wow, I can't believe I just said that. All right. But you see what I'm saying. For simplicity's sake in the problem, we'll assume a flat Earth. But anyway, all right. So 14 meters, it doesn't matter what the horizontal speed is. We know that the change in vertical position is negative 50 meters, right? Because it's going 50 down, so negative 50. Obviously, the Earth is curved. Obviously, I'm not a flat earther. I'm just saying for simplicity's sake of the problem, oh my God, Kirby Cannon, if you don't even joke. It's not, oh my God. Oh, here, this is Pandora's box. I've opened Pandora's box. I did a live stream. It's all, oh my, it's happening. Jesus Christ. Now people are going to, oh my God. Okay. Initial vertical velocity is 0. Acceleration vertically is negative 10. I'm not saying anything else anymore. I'm just doing the problem. All right. So I'm going to use delta x equals v naught t plus 1/2 at squared. But again, this part right here goes away because my vertical velocity is 0. So this whole thing just goes away. So I'm going to get delta x equals 1/2 at squared. My delta x is negative 50 because my displacement is 50 down. I start at the top of the building, I go down vertically. Half of a is negative 5 times t squared. So I divide by negative 5, I get 10 equals t squared, I square root. Then I get t equals square root of 10, which is like 3.1 or something like that. I forget. 10 square root of 10 is 3.16. So it's 3.16 seconds. All right. Oh, great. John's here. Great. Okay. Oh, it's doo-doo butter. Who's doo-doo butter? Sleep on your back, probably. Doo-doo butter. And yeah, keep your mouth closed. All right. Oh, is that Joel? All right. Anyway, so that's how you find the time there. Hope that helps somebody. I hope someone's learning. I hope someone's doing something. Susanna, I'm counting on you. Ilse, Isabella said she'd watch the stream. I hope hope one of y'all is actually getting something out of this. All right. So we'll do B real quick. What horizontal distance has the sphere traveled before striking the ground? Well, now that we know how long it's in the air for, it's pretty easy. So again, horizontal distance, right? We don't care about the vertical stuff now. So now we can use the equation delta x equals vt for the horizontal stuff, right? Well, who's blue is a loser in apes? Who are you? You gotta tell me who you are. All right. So now we know the horizontal velocity, right? It's 14. It told us that. That doesn't change. There's no acceleration horizontally. It's 14 here. My time, we found it in part A, was 3.16. So we just multiply these together to get our answer. That's it. So delta x is going to be 14 times 3.16. So 6 times 14. And I get 44.24. So about 44 meters of displacement. Blue is I don't know. You're talking about your fish blue, but you spelled it wrong. I don't know. Alright, what number is next? Are we good now? Or we want to do another one? I'll do a couple more. No, I'm not gonna take a break. I'm gonna finish. I'm gonna do everything, and then number 2, the next one. Guys, if you want practice problems, seriously, go to masteringphysics.com, go to the textbook, go to chapter 3, and do the odd numbered ones because the answer's in the back of the book. That's why I gave you Mastering Physics at the start of the year, right? Okay, 2 votes for number 6. All right, I'll do 6. I actually did 6 in 4th period, but I did because we had so much time, so it's only fair to do it for the rest of you guys. You're welcome. The very last one? I'm gonna do 6 right now. I already did the very last one. Here, whoa. Here is a picture of it, John. I'll leave it on the screen for a second. So if you got part A and part B, part C was throwing you off. It was just doing the Pythagorean Theorem to find the resultant vector, right? I'm gonna do number 6 right now. So I'm just showing number 5 to someone who asked to see it. All right, go back to number 6. All right, so this was the hardest problem probably on the whole thing. So let's do it piece by piece. So we got a golfer here, right? The angle is 75 degrees. When he hits the golf ball at 100 meters a second, right? So let's draw a better picture here. Hits it up 100 meters a second at an angle of 75 degrees. And then we got to find components. That's always the first step to find the components. Okay. I know you want. I'm gonna go through the whole thing because it's just easier that way. That way everybody can kind of, follow along. All right. So part A is what are the horizontal and vertical components of the ball's initial velocity. So as I said before, Vx will always be equal to the hypotenuse, 100 times the cosine of the angle, which is 75 degrees, and then Vy initial will always be equal to the hypotenuse, which is 100 in this case, times the sine of the angle, which is 75 degrees in this case. So go ahead and punch that in real quick. So Vy initial is going to be 100 times the sine of 75. Make sure you're in degree mode. 96.6 is what I'm getting. Yeah. And then 100 cosine of the angle 75 will be our 25.9 for horizontal velocity. Initial velocity is 50 meters. 50? What do you... Huh? 50. Oh my god, I'm dumb. Okay, why did I say 100? Oh, this is 100. Okay, I'm sorry, guys. This is 100 here. Thank you, Christian, for pointing that out. I'm sorry about that. So it's 50 there. My bad. All right, so 50. So it should be half that, right? So it's 50 sine 75. 48.3. My bad. 48.3, and it should be half this, right? So 12.45. Or no, that's not right. 17. Yeah, 12.45. All right. 50 cosine of 75. 12.9. Okay. Tried to do it in my head, but I couldn't. I failed. All right, 12.9. Sorry about that. Okay. You do me a quick favor and just point the camera out your window real quick. No. Can we do a random event, please, Mr. We have done 3 days. I'll think about it. So have you been watching for a whole hour? I still don't know how to put my phone calculator in degree mode. Oh my, Nick, I don't know if your phone calculator. Let me check my. Let me see if it's on. It's actually a good question. If you turn it sideways, take your phone calculator, and you turn it sideways, it actually goes into degree scientific calculator mode. It's probably in. Mine says degree mode up here in the top, up here in the corner. Nick, yours might have that too. You see that there's a radians button, right? There's a rad button that's to convert to radians. It's probably in degree mode by default, Nick. But you can hit the rad to convert to radians, but it's probably in the default to degree mode. I would imagine. Anyway. Okay. Now get that out of the way. Okay, so here's our components. There's part A. Let's go to part B. How much time elapses before the ball strikes the side of the building? All right. Now, we did one like this in the notes and stuff. If you didn't know what the horizontal displacement was to the building, but you did know the vertical one, you would have to use a quadratic formula like we did in class at one time. Okay. But thankfully for you, in this problem, we do know the horizontal displacement. So again, if it horizontal stuff, we don't care about vertical. So the horizontal displacement is 100, right? 100x. We know the horizontal velocity, which is constant at 12.9, because no acceleration in the horizontal direction. So how long does it take t to go that far, right? It doesn't matter what the vertical velocity was. If we're trying to go a certain distance this way, the only thing that matters is the horizontal velocity, right? It doesn't matter how high up you go, okay? So let's solve for this. So we're going to use the equation Vx, or sorry, let me erase that. Delta x in the horizontal equals Vx times t. We know this is 100. This is 12.9 times t. We divide by 12.9, both sides. And we got our t at 7 point something, right? 100 divided by 12.9, 7.75, yeah. So 7.75 seconds. And that's our t. Okay? We'll use radians like when we get a little bit when we get to rotational and circular motion, but not that much. A Magic Booster Pack is a pretty good bribe. That's actually a fair point. But don't spend money on me. I have a job. Y'all need your money. Keep your money. Put your money in a college fund or something. All right. How far? Okay. Now we got part B. Hope that makes sense. Everybody followed that. So 7.75 seconds. All right. How far from the ground does the ball strike the building? So what it means here is how far from the ground. How high up the side of the building, right? So how high up this way does the ball strike the building? Well, this is a pretty challenging problem, but now we have t. So we're going to use the equation delta x in the y direction equals v naught y t plus 1/2 a t squared. Now that we know what t is, we can plug it in and solve for our change in position in the y direction pretty simply. All right, we're just going to do the math. So delta x in the y direction equal to our initial y velocity, right, which was 48.3, times t, which is 7.75, minus 5, minus because a is -10, half that's -5, times t squared, which is 7.75, so I'm going to square that guy. Don't forget to square it. And we just plug in our calculator and get the answer. So we're going to get 48.3 times 7.75 minus, dang it, this is going to be 48 times 7. This is 374.3 minus minus 300.3, and that's going to be 74 meters. All right, so it's going to go up the side of the building 74 meters. Pretty high. All right, it's 74 meters up in the air. All right. Do you see? I did see. All right, I'll go do the graphs too. So let's look at the graphs real fast. So draw graphs. Now this is a graph of horizontal velocity versus time, and then vertical velocity versus time. John, don't take credit for my ideas, John. That's messed up. All right. So horizontal velocity does not change, right? It is constant because there's no acceleration in the horizontal direction. So what was my horizontal velocity? It was 13, right? 12.9, so basically 13. So how would the graph look? Well, go to 13, starts at 13, and it's 13 the entire, I cannot draw straight lines. It is 13 the entire time. You get the idea. Pretty straight, okay? All right, now for vertical velocity, what was our initial vertical velocity? Where do we start? Well, it's 48.3, right? So right below 50, right in here. Now, what the slope of a velocity time graph is acceleration. So the slope of a vertical velocity time graph is vertical acceleration. Well, the vertical acceleration of any object in free fall, projectile motion, is -10. So the slope of this line should be -10. So we go down 10 over 1, 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 and then we draw the line. Try to draw through the lines, but I did the best I could. So hopefully there you go. Hopefully that makes sense. You made the idea. All right. All right, so that's number 6. Any questions on number 6 there? I didn't see any in chat, but let me go back and look. Nope. Just Kenny trolling everybody, basically. All right, any other problems that we wanted to look at? We did most of them. We did quite a few. We did the entire that page. We did all but this one on this page. We did 6. We didn't do 4 or 5, but we did 3, 2. We did like 75% of this thing. Do you sell bath water? I don't know. No, I don't think so. I don't think so. Oh, it's Azul. Is it? Wait, blue is that Azul? Is that you? I don't know who the loser is. Is it Azul? I don't know. Do I have to do every one of these, really? Gosh. Is there one more we're gonna do, or do 4? Okay, Susanna wants me to do 4. Susanna, this 4? Because there's, I assume you mean this 4. I need help with Spanish. I'm very bad at Spanish. All right, Susanna, I hope you mean this 4. I'm gonna do this one. All right. I'm not gonna. If take a break on ending the stream is taking the break is ending the stream. So if there's one more you want to do it now. It's not that late. I can make dinner. The 4 we didn't do. Okay, so this 4. Oh, did we do the 4? I don't know. Which 4? We did the other 4, right? Yeah, we did that. Okay, so we did this 4. Okay. All right, we did this 4. Okay, ball shot in the air with initial speed of 60 meters a second, angle 32. All right, so we draw it out. Helps to draw it. Shot in the air, 60 meters a second. Velocity at 32 degree angle. So there's our angle, 32 degrees. Got to find components. It's always a first step. So we do 60 cosine 32 to find the horizontal velocity, 50.9. That's Vx. And then Vy is going to be 60 sine 32. So that's going to be 31.8. Ugh, sorry. 31.8 meters a second. All right. All right. Favorite food is like Indian food. I love matir, or what's it called? I can't remember the name of it now. Matir. I can't remember the name now, so I'll look it up later. All right, so we have this. What's part A? All right, what is the object's speed at the highest point in its trajectory? All right, so remember that projectile motion goes like this. So at the peak, right there, right at that spot, that's the highest point, right? There is no vertical velocity. It only has horizontal velocity, right? The vertical velocity at this spot is 0 because it's been slowing down the whole time because of gravity, right? Remember I drew those arrows during the lecture notes. I'll do it again real quick. So when the ball first launched, it's got horizontal velocity and it has vertical velocity. But as time elapses, the horizontal velocity stays constant, but the vertical velocity is a little smaller because gravity's pulling it down, and a little smaller still. Well, horizontal stays the same, but vertical gets a little smaller. And at the peak, there is no vertical velocity. It's 0 for an instant at the very top. So all that's left is horizontal velocity. So the total speed at the peak is just the vertical velocity, which in this case is 50.9 meters per second. All right. All right. Oh, hey, Quant. Yeah, I believe you. All right. Part B. What is the object's speed just before it strikes the ground? All right. Again, if you remember from lecture, I talked about how if you launch from a certain height and land at the same height, the launch altitude and landing altitude are the same. They're kind of like mirror images of each other. So because of that fact, right, on the way up, you're losing velocity. You lose a little velocity, right? You lose velocity vertically. But then on the way back down, you gain the velocity back that you lost, right? You start to gain it back down in the negative direction. What that means is that right as you hit the ground, your landing velocity is the same as your launch velocity. So if you launch with 60, right, you lose velocity on the way up, but then you gain it back on the way down, and so you land with 60. Again, you land at the same velocity you launched with. All right. Now, I want to be clear, that's only true, again, that's only true if you launch and land at the same height, right? All right. Any other ones that we want to do? Any other questions in chat or any other problem that we want to do? I think we peaked at 32 viewers. That's not bad. I've seen Twitch streamers with less people than that. All right, Mr. Chandler, do you want to buy a robotics shirt from me? I'll think about it. Only from me. Maybe. I'll think about it. Do number 5. Oh my God, Manny, can you do? Oh, Jesus Christ. Fine. I just built some Vex IQ stuff for Mr. Silverstone. Oh, is it? Did it get almost 40? That's pretty good. All right. Okay. On long level playing field, a player kicks a football. I mean, Manny, I've done this problem already. It's the same problem with different numbers. But I'll do one more. All right. So here we have it kicks a football with an initial speed of 24. All right. So here's 24 is an initial speed. That means the total speed, right? That means the resultant vector at an angle of 65 degrees. So it needs to be a little steeper than that, huh? Let's do that again. It's a little steeper. All right, so I got our components. The angle is 65 degrees. The initial speed is 24. Got to find components. Vy naught is going to be 24 times the sine of 65. So that's going to be 21.8. 21.75, and then the Vx is sorry, I don't know how to mute my mic. I don't know what that button mutes it. Vx will be 24 cosine of 65, which is 10.1. All right, now that we have our Now that we have our components, the question is for part A, at what time does the ball reach its highest point? All right, well, again, we know that special point at the height is when the vertical velocity is 0. So knowing that, and we also know the initial vertical velocity, so we can do the equation V equals V naught plus AT. We know that the velocity at this position here is 0, so I'm going to plug this 0 into this guy right here. 0 equals, my initial vertical velocity was 21.75 plus A is negative 10 times T, that's what I'm looking for, T. So I'm going to solve for this. I'm going to add 10T to this side. So I add 10T to both sides. I get 10T equals 21.75. I divide by 10. I get T equals 2.175 seconds. And that's how long it takes to get to its highest point. Part B was, what is the greatest height reached by the ball during the projectile motion? Well, now that we know how long it took to, this is how long it took to get to the highest point, right? The peak is its highest, the highest it's going to get, right? That's vertical displacement. So vertical displacement, delta x in the y direction equals v naught yt plus 1/2 a t squared. Well, now I know how long it took to get there, so I can plug this t in for both of these t's, both t's, right? Same t. And then I can solve for my change in position in the y direction, this guy here. That'll tell me how high I got. That's vertical displacement, right? So let's go ahead and do that. Erase the arrows real quick. Let's go ahead and do that. So we got delta x in the y direction is equal to 21.75 times my t, which is 2.175, minus 5 times 2.175 squared. All right, delta x in the y direction equals, let's see what that's going to be. Do my calculator real quick. 21.75 times 2.175 is 47.3 minus 2.175 squared times 5, 23.65. So we do all that, get our total height then. Our change in position in the y direction is 47.3 minus that, which is 23.6. So this thing's highest altitude, right? Its peak altitude is 23.6 meters. Right. Meme review? I don't know what that means. What does that mean? Meme review. I don't get it. I'm getting too old. God dang it. All right. Any other problems or you know what? For watching the stream and staying on this long, I'll give you a challenge problem. So let's do here's a challenge for you all. I'm gonna draw it on here. You bring this tomorrow, and if you bring me the correct answer tomorrow, I will give you, I don't know, I'll think of something, plus points on your test maybe or something like that. All right. So here's the question. We're on a cliff. It's not gonna be that hard of a problem. I don't think it's too hard. It's a little bit harder than these, but not too much harder. You guys can probably do it. Blue is a loser, yes, if you tell me who you are. I think it's Azul, but I'm not sure. Is it Azul? Tell me if it's Azul. I didn't see it in chat. All right, so we're on a cliff that is, I don't know, 20 meters high, let's say. On Earth. Okay, I thought so. All right, I figured it out. 20 meters high. Okay. When we're going to launch a ball off of this top of the cliff, but we're not going to launch it horizontally. We're going to launch it at an angle this way. We're going to launch this ball at an angle, angles to the horizontal of, I don't know, how about 20 degrees. Okay. I know I didn't see it in chat. I'm sorry. All right. Question is, I want to know a few things. I want to know, its launch speed is, I don't know, 30 meters a second. At an angle of 20 degrees. Okay. I want to know what is the highest point it gets to during its travel, and then I want to know how far this way it gets. All right. So I basically want to know its total vertical displacement, right, and its total horizontal displacement. Right. Show me your work and bring it out tomorrow, and I'll give you, like, I don't know, I'll give you a XP or experience or gold, or in the classcraft, or I'll give you points on the test or something. I'll figure it out. We'll make a deal. But show me your work and bring that to class tomorrow, and I'll do that. All right. Are there any other problems? Last call for any problems that you want to do. All right. Azul gets a pat on the back. Kenny, you're solving for total, the highest point the ball reaches during its trajectory, the highest position it gets to, what's the maximum height it reaches, and how far does it go horizontally. That's what you're solving for. Is there really only one more? I did all of them but one. Nuh-uh. Really? That one. Yeah, that's 2 more. And I didn't do the very first one. Alright, David's here. David Gomez just logged in, so time to end the stream. I hope you guys have a great night. I hope this helped. I really do. I know you guys are, again, having fun in chat. That's all good, but I hope it helped a little bit. So tomorrow we'll do some more practice with this stuff. Alright, guys. I'm gonna sign out. Have a great night. I'll see you guys tomorrow. Oh, I gotta do my outro. I have no life, you are my life, so always message me anytime, day or night, if you have any questions at all over physics or anything else. Alright guys, see you later. How do you end the stream? There's no button that says like stop streaming. Oh. Create stream? Oh. Oh, I didn't do it right. Oh well. Am I still streaming? How do I end it? Oh my god, I can't figure out how to end it. I'm seriously. How do you stop it? I'm such an idiot. There's no button that says like end stream or anything, so I don't know.